So first of all, let's look at some background ideas. Units and dimensions. Quantities in physics should always be considered with respect to the units for them. There's a bunch of standard scientific units called the SI units, and you need to be aware of them. But more importantly, when they mess up the units, that's an attempt in an exam to try and trick you. For example, you might be working at a speed. They ask for the speed in meters per second, but they've given you a number of kilometers or maybe even centimeters if it's like a toy or something, and you have to do a conversion. So you need to start becoming very OCD about the idea of, when you read a question, identifying the numbers and making sure that the units are in standard scientific units and spotting instantly when they're not, because I promise you it is a trap. There is also a well-known thing that if a human being reads quite a large paragraph of text, then what tends to happen is we remember the beginning of it and we remember the end of it, and we don't remember the middle bit. Is they will put a crucial piece of information in the middle of a paragraph of text in order to allow you to forget about it. So, and there are also phrases you need to be aware of, like released from rest. That phrase means U in Suvat is equal to 0. Another one is released from a great height. What that means is you cannot ignore friction. So there are phrases that they use which mean other things by implication, and you have to get used to it. This is a good example of the difference between knowing the physics and being able to answer questions. Knowing the physics is one thing, but being able to answer questions is a different skill. Having said that about standard scientific units, SI units, I would like to make a particularly important point here. Exotic functions. Now, I'm going to define what I mean by that. An exotic function, any function that is not a simple power. So I would say if something was like y equals x squared, that's not an exotic function. The kind of things I'm talking about are tan, sine, cos, log or natural log, exponential, those kind of functions. Here's the statement: exotic functions can not have units. So for example, you will never see in physics an equation that is like this. Y, if y is a position, say y is equal to sine t. In other words, something is varying as a sine function, sinusoidally in time. You might see y is proportional to sine t, but you won't see this. And the reason you won't see it is because dimensionally it simply doesn't make sense. First of all, the equal sign is really important, of course, and it means that the dimensions on the left-hand side are the same as the dimensions on the right-hand side. It doesn't just mean the numbers. And so that means if this was a position, then the units here are meters. And if this is time, t's time, then this is sine seconds. Now, sine seconds doesn't make sense. There's, in a physical universe like ours, there is no physical reality to the idea of having sine seconds. So this is why sine functions, cosine, etc., they must have no units. And it still wouldn't be acceptable because now I've got meters equals no units, even if I could get rid of them, and I'll show you how to in just a second. So what we must have is something here like an A is the amplitude, and that has the same units, meters. So now I've got meters equals meters times sine seconds. I need to get rid of the sine seconds. The way that I get rid of the sine seconds, and there's two different ways of doing it. You either shove something, a constant, in it like that, and B is a constant which in part is there to make sure the units disappear. So in other words, if that was seconds, then that will be per second, or seconds to the -1. Or you can divide. You can say A sine, and you could say T over tau, where tau is some sort of time constant, and it's got the units of seconds, because then I've got seconds on top, seconds on the bottom, and they cancel out to give me no units. I'm going to make a provocative statement now. Angles do not have units. in the same way that we talk about units. Now that you might think, okay, well that's not right, because we've got degrees, we've got radians. If any of you are geeky enough to have looked into this, because there's an interesting historical story about it, there's something called gradients, which is why your scientific calculator will go from D to R to G and then loop back to D again. Okay, well they're not units in the same way that we talk about units here. If that's the x-axis, and I say that direction there, then we call it theta. Now theta does have units in the sense of there is a way of indicating that direction, but they're not physical units in the way we talk about units. To convince you, if you're not sure, or you're daring to consider the fact you don't believe me, well, I mean, what would be going on there? That would be craziness. Let me draw a right angle triangle, because we love right angle triangles. And if I call that x and that y and that z, then Pythagoras tells me x squared plus y squared is z squared. But more interestingly, theta, sine theta is y over z, cos theta is x over z, tan theta, which of course is sine over cos, is going to be y over x. Now, when you look at that, that's meters, they cancel out. There are no units there. There are no units there. There are no units there because they're cancelled. It's a meter divided by a meter and they cancel out. Units in a formula work in the same way as numbers in a formula. If there's one on the top and the one on the bottom, you can cancel them out. Which means sine theta has no units. Therefore, theta has no units because I can't just create them from nowhere. As I wrote, y equals a sine omega t. That means omega must have the units of per second, because per second multiplied by seconds cancels out. And in fact it does. Omega is normally given as radians per second. Another one, n is n naught. This is radioactivity. E to the minus lambda t. Now lambda is not the wavelength. Lambda is the so-called decay coefficient. Coefficient is just a flash word for constant. In physics, we love to use complicated words for something that's very simple. It makes it all sound like flash and a little bit science fiction-y. And it's got the units of per second, because then when I have per second multiplied by seconds, they cancel out. So that's the first thing that I wanted to say about this. Also, it helps you to remember other formulas. If you look in the data booklet, you will see that big G is 6.67 times 10 to the minus 11. And its units are newtons meters squared per kilogram squared. Now, if you can't remember Newton's law of gravitation, if you look at the units, it will tell you that G looks to be a force times a distance squared, or an area, because it's got meters squared, and it's divided by an m squared. Now that's not quite Newton's law of gravitation, but it's close enough to help you remember it, because if you rearrange it for F, you've then got G m squared over d squared, and actually that bit and that bit are correct. It's just that that is an m1 and an m2. When you look at the units for a constant, it will help you to remember the formula that it came from. So units are very, very powerful. One more thing, a raindrop. I'll draw a raindrop. There you go. There's my raindrop. It's not a perfect one. Trust me, I can draw better than that. It's a raindrop and it's falling at terminal velocity v towards the ground. Which of the following is the correct equation for the temperature rise of the raindrop? Now there's two ways of doing this. One way is to do it like using physics, which is to say something like the kinetic energy is a half mv squared, and that's going to turn into thermal energy. So that's going to be mc delta t. So the temperature rise is given by, and then it's like a rearrangement. So you can do it the proper way. The proper way sometimes is not obvious to a student. There's another way of doing it that is, as long as you can do dimensional analysis, as long as you know the units and you know how to multiply or divide units, which is just like numbers, then what you can do is you can take the four answers, and they'll all be subtly different, of course, the equations that they give you, and just dimensionally analyze them, because only one of them will have the units of temperature. And that has to be the answer, because you're after a temperature rise. All the others don't. So it does mean you have to dimensionally analyze 4 equations, but they're normally not huge. You can do it, and when you get practiced at it, you can do it in seconds, maybe 10 seconds. So it might take you slightly longer to do it by doing dimensional analysis, but you will know that you are correct, and then you can move on and feel happy about life until you reach the next question, of course, and then it's like not a very nice one, because that's the way life goes.